Something is fishy. Greetings, by the way, I'm the Astro 30 and I'm looking at this power supply again. Now, I've got a 10 ohm resistor, 10 watt, connected across the common and the negative binding posts, and as soon as we apply the load, we can see we've got a current draw of 1.87 amps, which cannot be right. And I know isn't right, and I'll tell you why. It's because of Ohm's law. Ohm's law says it's not. Now, Ohm's law is E, as in voltage, equals current, I, times R resistance. So in that circuit, if we had a current of, say, 2 amps times the resistance, which is 10 ohms, that would equate to 20 volt, which is what you'd expect, but it's not. It's at 10 volt. So in order to work out what current we should have with a 10 ohm resistor at 10 volt, we inverse this to I equals E divided by R. And that's a really simple equation. That's 10 divided by 10, which equals 1. So the expected current draw should be 1 amp, not 1.89. So rather than trying to guess, here I've got an amp meter on the 10 amp high range connected in series with the green binding post. So we'll just turn the load on. Wah, wah. About 970 milliamps, 1.81. That is a fail. So what does that mean? Well, it could be that there is a calibration issue with this meter. There is actually an adjustable trim pot on the back of this module that you adjust for current. So I'm going to first try doing that. That's all the way down. That's not making any difference to the current adjustment, not by much. So it's not a calibration issue. So what I'm going to do is I'm going to remove this negative feed wire, or VEE wire, to the meter, because the meter is already at negative rail potential here on this current sense lead, and so the circuit will still work because both this negative and that negative are tied together. And I'll explain why in a minute after I've done it. Okay, and I got that negative lead to the module disconnected. As you can see, it's still working. Now look what happens when I turn the load on. Ha! Still out, but ha! I was right. So we've got about a 30% error on that meter, and well, unless I start playing with the shunt, I'm not going to get it any more accurate. But why has that current suddenly dropped on that meter display after I removed that negative wire? We've got our voltage regulator with a transistor, the pass transistor, which forms our positive voltage output, and we also have this negative line here, which on the schematic actually goes through a resistor before forming the V negative. So this is a 0.47 ohm. Alright. Now the negative for the 24 volt rail is coming off of the negative of the filter caps. So that's being fed into our BA meter, which I'll represent here with a little amp meter symbol. Alright, and that's now going into there. This is also a negative there, okay, because it's in the negative, out the positive. So that's the positive of the amp meter. These 2 points are actually electrically joined together in the circuit. And this already has a shunt resistor across it. Not sure what the value is, it's probably like something like 0.01 ohm. Now, with that shunt resistor there, and we're connected to negative over here, as well as here, we're effectively putting this 0.47 ohm resistor as a shunt across the meter as well, effectively. So that is why the current reading was out, is because this resistor was basically forming another shunt across this amp meter. That's my theory anyway. And as soon as I disconnect that negative line, which I'll tie up somewhere out the way, we get a semi-accurate reading. It's still 300 millivolt, or 300 milliamp I should say, out. And I'm not sure why, but if I played with the shunt resistor at the back of the ammeter, I'd probably get it more closer to what it's supposed to be. So now we know how not to wire up these cheap Chinese modules with those Banggood kit boards, because it does not work and you'll get an inaccurate current reading. So what I'll do is I'll wind the voltage up to 20 volts, because last time I wound it up to 20 volts we had something like 3.5 amp. And now we've got 1.3. Technically speaking, according to Ohm's law, that should be 2. So I wind it up to the full 30. 1.47. So it's not actually giving me a very accurate current draw at all. And I just confirmed on the multimeter current range what the values were at those voltages. At 20 volts I was looking at 1.9 amps, and at the full 30 volts I was looking at 2.3, I think it was. .1. So there is actually a drop there. But still that amp meter is way out. And well, technically there's nothing I can really do about it. So yeah, there's not much I can do about that except muck around with the shunt, which I don't really want to do. So I'm just going to probably leave it like that. So we now know we can't connect the VEE line of the module to the negative 24 volt and connect the sense wire, the big black one, to the negative of the output because of that OR47 resistor that's in the circuit. And I reckon they're using that resistor as their current sensing resistor for the current limit circuit. And so having the meter also acting as a shunt across it is going to change the value of its resistance, affecting the current limiting capabilities of the power supply module. So anyway, I just found that interesting. I'm a little bit disappointed that the accuracy of this is out. I'm currently drawing 0.18, 180 milliamp, according to the multimeter, at 1.9 volt into 10 ohm. But it's saying I'm drawing 100 milliamp. So for a basic, okay, how you doing sort of thing, like this is how much current's being drawn roughly, is okay, but it'd be a lot better if it was more accurate. Now, if anyone knows of a simple way that I can make this stupid meter more accurate than it is, let me know in the comments below, because there's really nothing much I can do back there with adjustment wise. So Anyway, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, have a great day.